Okay, we're about to introduce the very last one of the number sets that we're going to be concerned with in this class. Let's take a moment and review the story so far. We started with the whole numbers, but then we came up with this idea of undoing addition. We came up with this idea of subtraction, and sometimes it failed. So we needed some new numbers to make subtraction always work. The new numbers that we needed to make subtraction always work were the negative integers. So we kept going for a little while, and we were okay with adding, subtracting, and multiplying. But then we wanted to undo multiplication. We needed division. Sometimes division failed, so we needed some new numbers in order to make sure division always worked, and those were the fractions. Well, now we have a new thing that we've done, exponents, and we're trying to undo that thing, taking roots. And guess what? Sometimes roots don't work either, and we need even more new numbers. Okay, wait a minute. I'm telling you now that there are some numbers that are not fractions. There are some numbers that there's just no way we can write them as fractions. That also means that there's just no way that we can write them as decimals that end eventually, because that would be easy to turn into a fraction, or as decimals that repeat eventually, because I told you that we can write those as fractions also. Alright, I don't expect you to take my word for this. But before I show you one of these numbers, let me tell you something about square roots and see if I can convince you that it's true. If I take the square root of a whole number, either that square root is a whole number or it's something I can't possibly write as a fraction. Alright, how could that possibly be true? And how could I possibly know that that's true for every single whole number? Well, okay, let's say that I have some fraction and it's in lowest terms. So it looks like a numerator with some prime factors over a denominator with completely different prime factors. And this thing is in lowest terms. There's nothing in common. Okay, and now I take this thing and I square it. What happens? Well, in the numerator, I've got those same prime factors I did before. It's just that they show up twice. And in the denominator, I have the factors that I had in the denominator before, only they show up twice. But it's still the case that these are all different. So this fraction is still in lowest terms after I squared it. That means if the original fraction wasn't a whole number, so this original denominator wasn't 1, then the new fraction isn't a whole number either. If the original denominator wasn't 1, then its square isn't 1 either. So that tells me I can't take a fraction, square it, and get a whole number as a result. Any number that I square and get a whole number. So any number that can be the square root of a whole number. Either it was a whole number to begin with, or it's not a fraction at all. Okay? But, alright, so let's say, what's the square root of 2? Right? Well, what is the square root of 2? Let's see. 1 squared is 1. So the square root of 1 is 1. So the square root of 2 is more than 1. On the other hand, 2 squared is 4. So the square root of 4 is 2. The square root of 2 is less than 2. And that's it. That's the end of the road, right? Because there aren't any whole numbers between 1 and 2. And we just said the square root of 2 can't be a fraction, because I can't square any fraction and get 2. So the square root of 2 must be a number that I can't possibly write as a fraction. Numbers that we cannot possibly write as fractions are called irrational. Now that's not because these are crazy numbers that don't make sense. They're irrational because they cannot be written as ratios. But wait, you say, that's cool. I can put the square root of 2 into my calculator. I hit enter, and there we go. That's the square root of 2 as a decimal. No, that is not the square root of 2 expressed as a decimal. That is an approximation. So the first few digits of the square root of 2, right, really are 1.41213562, right, or maybe 61 and this is rounded up. But this is just an approximation. This is not the exact value of the square root of 2. Okay, so where do the irrational numbers fall with regards to our number sets? Right, remember before we had the rational numbers, and inside the rationals we had the integers, and both of those sets were divided into positive and negative, with 0 inside the integers being neither positive nor negative. Inside the integers, we had the whole numbers and the negative integers. And inside the whole numbers, we had the natural numbers, which were also the positive integers. Where do the irrationals live? The irrationals live outside of all of that. Remember when we said that integers were z because I was taken? I is taken by the irrationals. And now notice I drew the irrational half a little bit bigger than the rational half. In reality, it's way, way bigger than that. Most of the numbers are irrational. We just don't see them very much because they're hard to write, and they're hard to name, and they're hard to do arithmetic to. We have positive irrationals, we have negative irrationals. In among the irrationals are numbers like the square root of 2, the square root of 3, also things like the fifth root of 4, any root of a whole number that doesn't turn out to be a whole number. And we also have numbers like our friend pi, which is another kind of irrational number. If you put them all together, the big set of numbers that consists of the rational numbers and the irrational numbers, the positive numbers and the negative numbers, is called the real numbers. What, real numbers, as opposed to pretend numbers? Yeah, actually, totally as opposed to pretend numbers. Well, real numbers as opposed to imaginary numbers, which are objects that you'll meet later in your career. So the real numbers consist of all the rational numbers and all the irrational numbers, all of the positive numbers and all of the negative numbers. The real numbers is the biggest number set we're going to deal with in this class. And for the most part, we are not going to pay that much attention to the irrationals, except to notice when they pop up.